I'm going to bridge the gap between because I need to use the technology and apply that onto the basic civil engineering buildings and give various types of services. Basically, we are based in Bangalore and we are providing the consultancy services. We use various technologies as you all aware, the structural health monitoring is still to develop. Almost about 20 years I've been training people on SHM and doing projects on SHM across the globe. But in India, we are still, raising to that level wherein everybody starts accepting. Since this being ACA update, this presentation is going to be only the basics of the structural health monitoring, why it is required, not focusing on any of my projects nor any of the findings of those projects. However, this will give a complete picture of why there is a requirement of SHM to the present day structures. So as we all know, we are facing the present day density dilemma. That is, we have the existing structure and the old aging structure, which needs to be renewed. Now, very basic to all, that every structure is undergoes aging. Aging is deteriorating over a period of time, and every structure is also subjected to the harsh environment wherein it degrades at a faster rate. And the loading pattern is quite varying. Now we have a capacity and we have a demand. The demand keeps increasing over a period of time. And since this can be represented, all the variabilities can be represented by the probability distribution curve. At any point of time in the future, you can see the time varying probability of failure increases. Thereby, you can see that the demand increases the capacity. Therefore, you can see the slight distress or the deterioration rapidly increasing. Now, you can see there is a distinct difference between the maintained structure and the not maintained structure. So if you see in the maintained structure, to be very simple, the service life of the structure is reduced. So you can we'll highlight it. So you can see here if this is the intended service life, you can see because of the deterioration of not being maintained, you can see the intended service life. But in reality, there is some type of maintenance that takes place, whether it is reactive, corrective, or preventive, or predictive. Irrespective of it, the whole objective is to extend the service life. Although we may extend the service life, any engineering requires the optimal functioning of the structure. So this has to be done, where this has to be taken care by the maintenance regime. Now, to understand this, the performance word is it includes a strength as well as various other aspects, that is functionality also. The durability aspects is defined over the number of years. Now, any structure that's built in the initial day will be exactly the engineer's requirement. Okay. Then further, the deterioration takes place, and then we get into the limits wherein it is no more acceptable, and then we go with the regime of monitoring it or inspecting it. Then we go with the repair. Then further, once in a lifetime, as we all do by theory. By theory, we know that once in a lifetime it has to be subjected to some disaster, and therefore further to it the deterioration takes place, and this cycle goes on increasing. Now if you look at this graph, what you have to note is that the x-axis, the parameter along the x-axis, that is the age, and the parameter along the y-axis, be it anything, the strength, the performance, or any other factors, these two, and also the slope of these, if any of these parameters changes, there's going to be a huge drastic change in the overall understanding of the whole structure. So therefore, these parameters keeps varying. In order to understand this parameter, we need to have data. That is what is happening with the strength, what is happening with the time, what is happening with the temperature or humidity, and why the deterioration is taking place, what is the rate of deterioration. So what is required is data. Now, because of these combinations of aging, which we cannot stop, the increasing demand, which is ever increasing, and the aggressive environment, and other factors like the latest crash of the aeroplane, which we are not designed the buildings for. So all this lead to some deterioration, damage, and if in case you have a very bad, or if you are not having an inadequate performance assessment, thereby it increases the risk of failure, and we call it as the failure of a system. Now, in order to avoid this, what is required is knowledge why this system fails. Now, how does knowledge come from? From the data, then the information. From the information, the processed information, the well thought about information, which is put in a very systematic way, gives us the knowledge. So the probabilistic approach is being highlighted most of the times, and all of codal provisions agrees with that, that the data has to be taken, statistically understood, and the probabilistic approach is the best way to attain the knowledge. So we have two parameters. One is the measured parameter, and one is the derived parameters. Irrespective of the measurement, what is taken place in the civil industry, what happens is that every measurement contains uncertainty. These uncertainties of various causes, since because of the shortage of time, I need to rush, but still, the uncertainty in the measurement can lead to the derived units or the derived measurements to be also including the uncertainties. With time, this uncertainty increases. So therefore, although the data are so humongous, still the uncertainty lies in civil engineering. Civil engineering is a very complicated subject. Although it looks very simple to put a sensor and get a data, still the putting the static location of the sensor itself is a big topic, and type of sensor that is, and the sensor dynamics itself is quite different. So one critical step in the advancing this infrastructure management is to equip the infrastructure, and not just the infrastructure, and also the managers and the users with the techniques and technologies that minimizes human intervention. The whole idea is to minimize the human intervention. This approach moves beyond the subjective performance assessment. We are getting into the objective type and getting into a quantitative analysis and with qualitative guidance. Enable more accurate, and it is data-driven monitoring and evaluation of national infrastructure. So this has to be more emphasized, and that is the need of the hour, and that's why the structural health monitoring comes into play. We have various type of the technologies that is available, and basic definition of this is that a technological-driven automated solution, be it anything, it can be the first presenter already happened to give the beautiful technologies that is already developed. These technologies, when it is implemented onto the structure, it could be installed, it could remain in place, or it could be placed whenever it is required with the intention of capturing the data, be it in a very short time or for the continuous time or a period of time, for the purpose of objectively and accurately assessing the structural performance. This is the definition of why we apply the structural monitoring technology. The census does not measure damage. Okay, it measures the state. Okay, so therefore, the structural health monitoring, we have so much of technology, but it doesn't rule out the old school of philosophies, like, visual inspections, the routine assessment, remote sensing, the non-destructive. It doesn't rule out. So most of them, it has to be complemented and it has to be supplemented. This has to be understood. And the prime objective of this is to lower the maintenance cost and increasing the reliability of the structure. Okay, very, very important. And this is a proven technology. Okay, so this has been implemented on various structures over a period of time, from its starts to the end of its life. We've been doing various steps of testing, which is done. And they give up various names in various sectors, in mechanical engineering, aerospace engineering, in hard disk monitoring also. You can call it as usage monitoring, health monitoring, maintenance monitoring. It could be various monitoring schemes that it is implemented for. Now, basically, we are civil engineers. We look into two sectors only, the new build and the old ones. Can it be implemented? Yes, it can be implemented on the new buildings, and it can be implemented on the old buildings. The new buildings, it can be implemented as a preventive tool. On the old existing buildings, it can be implemented as a warning tool. Now, this is a basic example how the building, since if nobody is an idea about SHM, it can be implemented on a newly built structure. It can be implemented on an old structure, wherein we collect the data, we check the data, then we check the model that has been built on the simulation, like a FEM model. We update the model, we call it as FEM updating. And therefore, this cyclic process goes on, to understand, to bring the, digital twin. Overall, the monitoring technology enhances the safety, efficiency, and sustainability of this modern infrastructure, whether it is existing or the new one. And as this evolves, it is going to have a greater impact on the construction industry, because that is also a new business, and there is an ever-ending war now. It's already started. So most of the, the testing experts and the demolishing experts are going to have huge business, I believe, although it is a disaster that's taking place. But it's paving a way for the most resilient and intelligent infrastructure. I thank you for giving me this opportunity for this presentation.